And during the past decade, we have been advocating for the adoption and development of solutions around Asia. We organize events related to open source. Bangkok, Thailand, Vietnam, Indonesia, India. We also have a summit in China. And today we are very happy to co-organize this event together with ByteDance Open Source Program Office and Group Open Source Program Office and Cloud. The event of today. So we put together a program for you that highlight a number of innovative open source solutions. I'm gonna name a few of them, and then the speakers that we have here today will go more into the details. So we have CloudWeGo. I don't know if anyone heard of CloudWeGo. This is an open source middleware set developed by ByteDance, and it helps to simplify the construction and management of enterprise level cloud native architectures. Another component of CloudWeGo that's going to be presented today, which is KaiPack. This is a high performance remote procedure core written in Golang, also developed by ByteDance. And we have another tool that's called Layauto. This is an application runtime developed using Golang as well by Ant Group. Another project of Ant Group that's quite famous already, maybe some of you are aware of, which is Complex, a modular development framework to help transition to from traditional applications to serverless environment at a minimal cost and effort. And finally, last but not least, if you were here the last meeting, you heard a lot about our clouds and what they do in terms of open source. Today, we also have another project from our cloud, which is Workbridge, a tool that is designed to optimize mesh performance using ABPF. Okay, so the agenda, you can see on the stage here, we have 6 presentations today. Every presentation will last about 15 to 20 minutes and followed by 5 minutes Q&A. We have prepared some presents here for you, sponsored by CloudWeGo. So for people who ask questions and share ideas or examples that they can use inside your company. Okay. This event is being streamed online, so we do take questions from online. So if you have any colleagues that cannot make it here today, it's streamed on YouTube, LinkedIn, and also X on Twitter before. You are free to take any a photo of the slide, whatever you want to record for your own memory. We also share the slide later on at the end of the meetup. What else I want to say? If you need to use the restroom, right outside on the right hand side. So there is one for men and further down for the women. Okay, so with that, I would like to introduce our first speaker. So I have here with me today Luo Guanning, the community manager and architect at CloudWeGo. He's going to talk about, of course, give us an overview, introduction of CloudWeGo. Are you ready?
Okay, ready. Thank you. Thanks for the introduction. Thank you. Hello, everyone. Good evening, everyone. My name is Guanming Luo. I am one of the hosts of the meetup, and also I'm glad that I will be the first speaker tonight. I hope everyone will enjoy this wonderful evening and also can benefit from the sharing and the discussion coming soon today. I came from ByteDance and also the community manager and also the architecture and maintainer of CloudWeGo community. My topic today is CloudWeGo introduction. Okay, let's come to the agenda today for my topics. First of all, I will tell you what is CloudWeGo. I think many people might be interested, might be curious. And secondly, I will sharing what problem does CloudWeGo solve. Last but not least, I will sharing some use cases Okay, let's come to the first part. What is CloudWeGo? Well, here, as you can see from the slides, CloudWeGo is a set of microservices middleware developed by ByteDance to build enterprise-class cloud-native microservices architecture. It's a very long sentence, but if you look closely, you will catch up some highlighted keywords. Firstly, it was developed and open sourced by ByteDance. When you look at the history, in 2018, we had about around 7,000 of online microservices. However, by 2021, the number had exceeded 50,000. In September of 2021, we decided to open source the microservices middlewares to help more developers. And secondly, it is an enterprise class microservices middleware solutions, which means that you can use it in your own company mindlessly. And last but not least, CloudWeGo provides both Go and Rust solutions. So if you are a fan of Go or Rust, congratulations, it might be your cup of tea. Okay, after a brief introduction, let's take a look at what are the core features of CloudWeGo that CloudWeGo provides. Firstly, the keyword is high performance. We developed many underlying technologies to support high performance. And my colleague, Joey, will sharing more detail in the coming presentation. The second one is stronger extensibility. We not only provide many out-of-box features, but also provide a set of interfaces for customization. The third one is multi-protocol support, including HTTP, Swift, and gRPC. The first one is the built-in code generation tools. It provides users with usability and will save your time in do coding. Besides, CloudWeGo is also cloud native and AI native, which I will introduce later. And most importantly, high availability. You should have no worry if you use CloudWeGo to build your core business logics, because ByteDance already used that in our internal system for many years. Okay, so far we know what is CloudWeGo and its core features. But what project that it truly provides? This picture will give you the answer. For the left side of the picture is our Go ecosystem. It provides Go RPC framework, Calyx, and Go HTTP framework codes. But below the framework layer, CloudWeGo provides many high-performance sub-projects in codec, network library and runtime, and many tools middlewares. For the right side, you can see it's our Rust ecosystem. We have Wallow. This framework provides Swift RPC, gRPC, and HTTP framework, and also many other Rust ecosystems. Next, let's take a look at the CloudWeGo community. We can't be successful without the help of the community members. Based on the latest statistics, CloudWeGo now has around 400 contributors in total. They're coming from different countries, covering different areas. Contributors here has a very clear growth path here. Every contribution values and will get reversed physically and spiritually. So you guys are also welcome to join the community. On the other side, CloudWeGo now has more than 170,000 individual visitors who have visited the CloudWeGo website for guidance, knowledges, tech blogs, and CloudWeGo related news. Those individual users are coming from China, Singapore, United States, Japan, Indonesia, and many other countries, including countries from Europe, Australia, and Africa, almost covering the whole world. Okay, so far, let's already sharing what is CloudWego, but what the problem does CloudWego solve? That's the second part I want to share. In microservices architecture, that is also the core topic today. Communication and governance between services are always very important issues. CloudWego provides a set of middleware solutions to focusing on solving the problems of communication and governance under microservices scenario. Firstly, in the scenario of RPC, Calyx, the Gona RPC framework, provides one-way ping-pong and bidirectional streaming for message tab, which can be used in different cases and scenarios. To provide high availability, we provide many service governance capabilities, such as service discovery, load balance, circuit breaker, retry, timeout, fallbacks, and so on. Most of those features have been provided with default implementations, and users can also choose to integrate with flexibility with your own customization. In the second scenario, which is HTTP, the Gona HTTP framework provides out-of-box support for HTTP 1.1, HTTP 2, HTTP 3, and WebSockets protocol. In addition, due to its layout design, you will be very easy to do the custom implementation for the protocols to adapt to your own case. And to solve the problem in HTTP and web applications, Hertz provides many out-of-box middlewares listed below, including cross origin resource sharing, JSON Web Token, pproofs, SDKs, Swagger, Sentry SDKs, and so on. The second capability that I want to address is code generation. Calyx and Hertz, as a framework by default, provides built-in code generation tool. For those who want to use Calyx and Hertz in one team or in one services, we want to unify the user experience. Under this background, we developed a tool called CWGo. And this tool will allow you to unify HTTP, RPC, DB, including MySQL and MongoDB, so that you can generate the codes at once. In the future, we will support more features. My colleague Guanyu Song will sharing more in detail about this tool. And the third capability that I want to highlight is cloud native that many people might be interested in today. CloudWego is very friendly to cloud native ecosystem. And you can easily run your microservices and to publish it in the clouds. The features including Kubernetes and container friendly. Suppose integration with Istio with multiple discovery service protocol. And suppose Prometheus and Open Telemetry for metrics and tracing. Suppose graceful shutdown solutions and many other cloud native features. If you take a look at the picture on the right side, you will find Calyx integrates with many cloud native technologies, including the projects from CNCF. The first and the last capability that I want to mention is CloudWego is also AI native. In the past 2 years, we all know that AI application grows at a very incredible speed. And so does in ByteDance. To support the AI scenarios, we developed, CloudWego quickly developed high-performance RPC streaming through Swift. And we also supported the server-side events technologies with the help of the CloudWego community. The server-side events is also called in short SSE. It's a standard allowing server to push real-time updates to clients over a single long-lived HTTP connection. It is unidirectional. while only servers send data to the clients. SSD is simple to implement and efficient for text-based data, but it cannot handle bidirectional communication or binary data. While RPC streaming allows for bidirectional or unidirectional streaming of data between client and server over various protocols. Commonly used in HTTP2 over gRPC. It is suitable for more complex interaction, such as chats and data transmission, real-time data transmission. It supports binary data and bidirectional communication. However, RPC streaming is usually more difficult to implement, and you need to do more difficult, complex configuration. Okay, so far we have already shared some of the capabilities that CloudWeGo provides. Let's conclude and summarize. What do we need? Why do we need CloudWeGo? And what does CloudWeGo plays in the role in the microservices development process? Let's look at the pictures. Developers can use CloudWeGo to build its microservices. In this case, CloudWeGo provides its core features in the RPC and the microservices. And that is the core of the CloudWeGo. However, in the dev process, you need more, not only RPC. CloudWeGo provides tools to generate scaffold codes, both client-side and server-side. That's one of the capabilities listed in the right side. And in the distributed system, CloudWeGo also provides service governance features for east-west traffic, provides observability for debugging and monitoring, provide registration and discovering for auto-scaling, provide config management for dynamic control, and also provide many middlewares for securities. After writing all your business codes, you can easily upload your mirror and run it in the cloud. Now, many public clouds by default support Calyx in their Microservice-related cloud services, including Alibaba Cloud, Tencent Cloud, Huawei Cloud, and Volcano Engine. Okay, then we come to the last part. We were showing what are the use cases. CloudWeGo can be used to build a variety of other applications, such as web application, backend platform application, and also internal system applications. Industry adoptions including many areas like gaming, security, e-commerce, and specifically AI. As you can see from the slides on the right side, all the business from ByteDance uses CloudWeGo to build its own applications, including Douyin, which is the Chinese version of TikTok, and Jianying, which is also the Chinese version of CapCut that you might already install in your cell phone. We have also many other users outside of ByteDance. The first group are the users who are using Go by default. We have some successful use cases. They are coming from Huaxin Securities, Sima Inc., and Shumei Technologies. The first one, Huaxin, listed here. They use this Calyx and to make their new apps at the very beginning. And we have Sima Technologies. They use this Calyx. Or compared with gRPC, the think Calyx has better performance. And they successfully integrate Calyx with Istio to build its microservices governance system. And we also have the Shumei Technologies. They originally used Apache Swift, and then they shift to Calyx Swift for service governance features and more specifically, the high availability provided by Calyx. The second group are the enterprise users. They shift from the other languages to Go. Well, this is more interesting. Firstly, let's take a look at the Taiwan game company. They originally used PHP to build their internal SDK systems, and then they choose to switch to Go using Calyx and Hertz to build the new microservices. The second company listed here is Thunder Securities. They originally used in Java and is specifically using Double as a framework. And then they shift to Go using Calyx to build its new microservices system. And in the end, the funds gained a lot of availability and performance. The last one is the Construct. They originally used in Python, and now all the new applications are shifting to Go, using Calyx to make their new microservices architectures. And they successfully integrated with Istio for service governance. And they published all the applications in Alibaba clouds. Okay, so far I have introduced what is CloudWigo, what problem does it solve, and what are the use cases. If you want to know more, please visit CloudWigo website, CloudWigo GitHub, and also please follow us in Twitter. If you want to get in touch with us, welcome to join the Discord channel that is listed at the middle. You can scan the QR code to join our channel if you haven't yet. And if you are speaking Chinese, you may also join our official chat group and follow us WeChat public accounts. And that's all. Thank you. Thank you for your listening. And I hope you can, yeah. If you have any questions, then you may ask it now.
Thank you, Quang Minh, for the insightful presentation.
Thank you.
Yes, so I mentioned before, we have some friends here for people who have interesting questions. Any questions?
Just a quick one. It's
Okay.
interesting to know that CloudWigo uses for Rust and Go.
Yeah.
Interesting into know if there are plans to support other languages or other technologies in the future.
We do not have plans for other languages. Yeah, right now but we have plans for the framework in AI agent scenario. But the main languages covering Go and Rust. Okay, thank you for your question.
How well is the documentation for this and how much is beginner friendly?
Sorry, maybe you can hand over the microphone.
Yeah,
okay, this. Okay.
I just want to know about the how you are going to manage the security.
Security.
Yeah, I mean, like,
Uh-huh.
do you have any code standards, any warning standards, how
Well, okay, I see. In the web applications, we provide many middlewares, like the JSON web tokens, and we have also the cross origin resource sharing stuff. And we will guarantee the communications through the TLS. What is the? It is a short name for to secure your communication. Well, those are also both supported in our HTTP framework. And if you're using RPC framework, you may switch to the standard network library, and you will be able to support the TLS protocol. Okay. Well, we have the last question. Just to the time, maybe this guy. Okay, this one.
Yeah, I wanted to know about what is the documentation for this, for developers and users, and how much is beginner friendly.
How much is English speaking?
Beginner friendly.
Make it friendly.
Beginner friendly.
Friend.
New people can.
New beginner. Okay, I see. Yeah, for the documentation, if you visit the CloudWigo website, you can go to the project page. There is a separate page called Getting Started. In the Getting Started page, the newbies can learn from how to build an HTTP application and RPC application from scratch. And now we also make some new videos for the new beginners, and this will be published soon, maybe later this year. But firstly, I think you can first go to the website and check the Getting Started doc, and you will be able to quickly set up an application based on our frameworks. Okay, thank you for your question. Thank you, everyone. Okay, we can communicate later. There are more questions. Thank you. Okay.
So, thank you very much. So I have copied up next. Make remote the feature called faster than fast with a technology called ByteDance. And I would like to invite Wang to wait, the maintainer of ByteDance and network and how we go.
Okay, thank you, Tang. Hello. It's okay. Okay. Good evening, everyone. I'm Joey Wang from CloudWeGo organization, and I'm excited to share you the performance optimization journey of KiteX. And of course, I'm the maintainer of the two projects. One is the KiteX, and another one is the NetPole. Okay, because since the topic of tonight is the microservice. So firstly, I want to discuss about the cost of microservice. Secondly, I will share some cases that how KiteX minimize the CPU and the latency cost. And then we will see some benchmark result between KiteX and other RPC framework. So for the first part is the cost of microservice. Before we talk about the microservice, let's just go back to the age of monolithic architecture. At that time, as you see in the picture, we organize different modules in a huge monorepo, right? And different modules will communicate with each other by function call. And the cost of function call is very simple. It's just maybe 10 nanosecond because it's just a pure function call. But there have some significant maintainability and stability costs because first, multiple team will develop in same code base, and if you do that, maybe you will find that it's very hard to develop right. And another thing is if one module crash, and the whole service process will be crashed too. So that's why we have moved to the microservice architecture, which has become the most popular architecture today, and that's why we're here. At this time, you will see that different services communicate with each other by RPC calls. Sorry. Okay. By RPC calls, right? And of course, the RPC calls will transmitted by network. And every service have the maintainability and the stability. Because the different team are responsible for the different service, and no need to care about other service. And if one RPC fail, and it can try to call another one, so there are more stability. But the RPC call cost is very huge. It's maybe up to 1 to 100 milliseconds. So let's say what constitute the cost of RPC. As shown in the left picture, you will see it is a very typical RPC service. The RPC service, because you need to read a request in, and you process the request, do some business logic, right? And then you need to write the response back. So let's begin from the bottom. The Linux kernel will read the real data from network, and then the framework will read the data into a read buffer, and then will decode to a request object, and then the response will be encoded to a write buffer, and then over network. So we can see there are two parts of cost. One is the CPU cost. It's included codec, which is encoder or decoder, right? And another is the IO system cost, which is also very huge in the online system. And another thing is the latency cost. One is the kernel thread scheduling, and another is the network transmission. So we can say that's the challenge to move to the microservice architecture. But we need to fix it. So we create CatX. CatX is a high performance and strong extensibility Golang RPC framework, and helps the developer to build a microservice. If you are developing microservice in Golang and are concerned about the performance, maybe CatX will be a great choice for you. So let's move to the part 2. We reducing the CPU cost by optimizing our CatX codec. Before that, let's talk about what is codec and why we need it. As shown in the picture, let's start from the bottom 2. One buffer needs to, one buffer when that data comes from the network, the socket the data will come from the kernel space buffer, and then will copy to a user space buffer, and then mostly is the framework will decode and decode the data from user space buffer into a request. So we can say that codec is just a help to translate the data view between human view and machine view. Human view is for the developer, and the machine view is for the network or Linux kernel or CPU, right? And the codec is very highly CPU intensive. With our online machine, it consumes over 20% CPU usage just for the codec. So that sounds very horrible, right? So that's the challenge we meet. So the first optimization is to optimize the codec. The first thing is no copy rate. The left picture shows a typical way to read a data from user space buffer. You can see there are two memory. One is the user space buffer, and another one is the new string. Because for example, we now have a request here, and the second field is string. So we need to create a string first, and then we need to copy the data from user space buffer to the hello to the new string. So there is one copy, right? But we may have many fields, so there are lots of copy in our system, and the memory copy is a killer for the CPU. CPU don't like the copy work because it's consume too many CPU. That's why we do the no copy rate, which shows in right picture. You will see the request field 2 just use the user space buffer memory directly without any malloc. And another is no copy write. It's very similar with the no copy read. The user space buffer will use the memory of request 2 directly, and will not create any malloc. That's the no copy read and write maybe will seem very simple, but it's not easy. Because for that, not every buffer structure can support no copy read and write. If you write some code for that maybe you will understand. So we design a new buffer structure, which called the link buffer. The link buffer is composed of multi-single buffer node. As shown in the picture, for example, we have a response structure, and it has many string fields, like field 1, 2, 3. And in this case, every field will be wrapped as a single buffer node without any copy, because it's just a node. And the link buffer is just work as a linked list. So, and then with the help of write-v system call, which is provided by Linux, could allow us to write multiple buffer node with a single system call. So there is no copy work, and there is no copy work, and there is only one system call. That's the key to the no copy read and write. Another optimization is reduce the object malloc, because we are using Golang, but and Golang is a language with GC. So the garbage collector, for the garbage collector, less object malloc means less GC work, and of course less CPU usage. The fields like map or list will contain multiple points. There are two ways to create multiple objects in Golang. The code A shows a typical way. Maybe you are right, Golang is maybe the normal way you create a multiple object. Here, we will, in code A, we will call malloc n times, and then we will create n points. And the code style B, it just create one big point and only call one malloc once. But why code B is better? Because first, GC only need to scan the bigger point once, because we only just have one bigger object. And next, the contiguous memory address will make the CPU cache happy, because there is only one object, so the memory, of course, is contiguous. Oh, so let's move to the third part. I will show you how to reduce the latency cost by optimize KTX network layer. Before we talk about the optimization, let's say what's the issue of GoNet library. As shown in the left picture, for the design of Golang runtime, it will, of course, RPC server will accept many connections, right? And for Golang, every connection will create a coroutine for it. So it will lead to a very high coroutine scheduling latency. And the native read and write API in Golang does not support no copy read and no copy write ability. So, what happened? Okay, so that's why we create a new project called NetPo. It's an alternative to GoNet library. NetPo have two advantages. One is the high throughput. We can see in the left picture, there are connections here. You will see that it only stores the connection FD in memory and without any coroutine. And if a connection has some IO event like read and write things, it will start a coroutine to do that. So it helps us to create a million connections without any coroutine. And it also supports the no copy codec. And another advantage is the low latency. Because it's independent from the Go runtime scheduler, it has its own epoch loop. So it will have lower latency than Golang. And it write data within the same coroutine, so it could enhance the cache efficiency. So after saying so much, let's say some benchmark between KTX and other RPC framework. We picked up some well-known Golang RPC framework here, and the most famous one is gRPC, which is the gRPC Go in GitHub. Yeah, both in throughput and latency part, KTX is always the best performance framework, and the data source link is at the end if you have interest. Because today we just have 20 minutes, so I just show a little work KTX did in past few years. But we also create many other projects on the CloudWego family. CloudWego is a big family to gather all efforts we did in microservice field. For the server framework, we could use CatEdge for Swift and gRPC protocol, and we have hosts for HTTP protocol, and for the serialization, we have Sonic for JSON. I think everyone uses JSON, right? And we have FastPB. If you hear about it, it's a protobuf is a protocol come from Google, but now it's very popular. And we have FastPB for protocol serialization, and we also have the Frugal for the Swift. For the I/O layer, we have the network mentioned before for the network, and we have SHIM-IPC Go, which is the shared memory IPC communication library. And that's just a little of our project. We have more projects, but if you have more interest, you could find the GitHub, go to GitHub, find more information. Okay, that's my sharing today. Thank you, everyone.
So listen here, we have
Okay.
time for one question.
Okay, so for the last slide around the serialization layer,
Yeah.
I wonder what is how we go to follow this system framework gRPC. Because I think those framework already do the serialization without encoding and decoding. I'm wondering what's the additional things that how you go.
You mean what we do in gRPC protocol, right?
Yeah, the serialization layer.
Yeah, because gRPC uses the protocol gRPC uses the protobuf, right? So that's why we create a FastPB, because we support gRPC protocol, and the serialization protocol is the protobuf. So we create a FastPB, and yes, there are some optimizations for the FastPB, but it's very very hard code, and it's too much detail. But most of it is the same. So the logic is same to reduce the object on malloc, and then do not use the reflect, because if you use Golang protobuf, you will know there are too many small object malloc, and there are too many function calls for the protobuf codec. So we need to reduce function call, reduce the object malloc. That's how we do it. But the further detail is maybe the code will tell you more detail. Yeah.
Thank you.
Thank you.
Thank you very much. Actually, we are running a little bit tight on time, but Drew, we're going to be here until the end of the day. You can question later.
Yeah, we can discuss it later. Yeah.
Okay, thank you. So up next, so we have a presentation about improving development efficiency, and I would like to invite our next speaker, Fan Quang Yu. So he is the maintainer of CAP and CW Go at Cloud.
Okay. Hello, hello everyone. My name is Guangyu Fan, and I'm infrastructure engineer at ByteDance. It's my pleasure to be here today to share my insights on key to efficiency that we insight into scaffold code generation for CWGO to enhance development efficiency. With that said, let's go started. In this sharing, I will cover the three sections. The first is overview, that I will introduce the challenge and the solution for the Clovico project performance development. And the second is that the key content for the sharing. I will introduce the CWGO tool for enhancing the efficiency for the Clovico project. And the third is the feature planning. My goal is to provide you with the practical knowledge and the best practice that you that can help you to apply to your own project or workflow. Okay, this is the first section.
CloudWego provides two microservice frameworks for the Golang. For the Hertz is a Golang HTTP framework with high performance and extensibility. For the Katax, it's a RPC framework with high performance and supporting multi-message protocol. The CloudWego project has the same developer flow. The first is installing the scaffold tool that used to generate a framework scaffold. After this, we will write idea for the protobuf or Swift that used to prescribe the interface specification. After that, we can generate a framework-based code based on the idea and the scaffold tool. Finally, we will complete our business code and deploy and launch the service in our produce or test environment. For install tool, currently CloudWego provides all needs the following tools for quick development. HJ and Katax is the scaffold tool for Hertz and the Katax framework. And the validator is a request parameter validating tool for Hertz and Katax. And the compiler contains the Swift.go and the Proto-C that used to pass the Swift or Proto file. Although we provide much of tools to facilitate the quick development, there are still many challenges to be faced. The first is multiple tools. The first is multiple tools that cause many learning costs. For example, we need to install more than 5 tools before we starting development. Furthermore, HJ and Katax have difference in usage and ideal specification that further increase the cost of use. In addition to this, the project layout template generated by the currently scaffold tool is more basic. Users usually need to add a lot of commonly used components to realize their goal. Finally, the current tool lacks of CORD code generation, which is a very useful feature for the user. To address the above challenge, we have provided the solution CWGo. It's a sort for CloudWego all-in-one. It addresses the above challenge in the following 4 ways. The first CWGo unifies and integrates HJ, Katax, database, and other related tools to provide an all-in-one SaaS way. The second, CWGo abstracts and unifies HJ, Katax, generating capability and only keep the simplest and the easiest feature. The second, CWGo provides richer and more complete default code layout to help user complete the initialization of various features in advance. The last, CWGo extends the feature to provide hex, database code generation, and other related capabilities. Next is the second section. This section describes the full features of CWGo and how to use it. The first is installation and usage. We can install CWGo tool by the go install command. CWGo mainly has server and client subcommand. For the server, it can generate a Hertz or Katax code based on idea for HTTP or RPC service. For the client, it is used to generate a Hertz or Katax client code for calling the target service. Here I provide a video to show how to the basic use of CWGo. Firstly, we can write our Swift idea. This idea defines one service which one measured. Naturally, we can use the CWGO server and the client command to generation the server and the client code. Like it's so the default layout for the CWGO. And naturally, it will show how to create a Hertz service by CWGO. It's similar to the RPC. Based on the above demo, I will first introduce the overview of the code layout generated by the CWGO. The default code layout for CWGO is MVC structure. It can help user developing quickly, and we add a BJ director for helping user initialize the database connection and other database operations. And we add a unit test file and initialize the test code to reduce the workload for user to write test. And furthermore, we also add the necessary common logic for the handler to help user to quick complete the business code. The HTTP code layout is similar to the RPC layout. This is because we want to help user sell as much of the details of the framework as possible. Furthermore, the HTTP layout only adds extra BJ router directory for the HTTP route. In addition, CWGO also offers the ability to customize the template to help users achieve their highly customized code generation. It has the following features. The first is that you can modify all the default generated code if you wanted to do that. The second is that you can add your own customized template and get all past IDL information to generate code. The last is that all the template is defined by Go template syntax, and the CWGO adds a lot of useful template functions. You can see the template extension link for more usage details. To facilitate template management and enable template usage in collaborative scenarios, we have provided two template management ways. The first way is local storage. You can store the template file in your project and generate code with it. And the second way is remote storage. You can store the template file in the Git repository and use it by Git HTTPS or Git SSH. It also supports branch feature to help you better test and use the template. Naturally, I will introduce an interesting feature called CWGO hacks. Currently, if you want to listen both HTTP and RPC requests within a single process, we would either have to listen on different ports with the same process, or use a gateway in front of the process to performance protocol conversion. However, with the hacks, we can quickly process both HTTP and RPC requests on the same port. Hex is a sort for Hertz and KTX, meaning that it integrates the Hertz and KTX frameworks at the same time to provide a unified form for CWGO microservice. As shown in the picture, when the request enters the business process, the hex will do protocol sniffing in the transporter and passing the HTTP or RPC request to the Hertz or KTX for processing. The implementation is that both Hertz and KTX use the same networking library network and have the ability to optimize the transporter to enable more interesting feature. The hacks can the development efficiency. In addition, CWGO has added the database code generation. The thirdly is CWGO MyCycle. CWGO integrates the Groom gene to generate CURD code by default. User only need to add the database type, and the DSN can quickly generate the CURD ORM code. Furthermore, MongoDB is also a no-circle database that we can often use in development. We have observed that users often encounter some problems with using Mongo. The first is Mongo is more troublesome to use in some scenarios, reducing the development efficiency. And the second is Mongo doesn't support translations, block operation, and other operations. The last is there may be incompatibility between different versions of Mongo that may prevent users from using advanced features. As a result, CWGO developed the CURD code generation for Mongo, which solved the both problems. Now, let me introduce how to use this feature. Firstly, it's structured in Swift map Mongo collection, and each field maps element in the collection. Then we can use function tag to mark the mapping of the fields. And lastly, we can use Mongo point function to specify the CURD function to be generated. This function rule can be found in our document. With that done, we can use CWGO doc to generate the CURD code. The graph shows the structure as well as the specifics of what it generated. The content of user repo and user repo Mongo are the ideal defined Mongo CURD code, and is called corresponding implementations. The above describes what CWGO has done for developing efficiency. We will continue to do it in the future as well. The first is IDL to Swagger. Swagger is a very common open API description tool, which is similar to the IDL. Therefore, we are working on the interconversion of Swagger and IDL to help users better manage their interface. And the second is generate a row circle based on IDL. Using ORM could reduce performance for the service and may cause the online problem for our service. So we will also develop an ability to generate the row circle based on IDL. Lastly, we plan to develop IDE plugins to support users in developing ColourWayGo projects. For example, we will developing a VS Code or Golang plugin to generate a ColourWayGo service with one click, or we can supporting generate a code job MQ customer code, and so on. Okay. If you are interested in CWGO or ColourWayGo, you can access this link. Okay. Thank you everyone. Thanks for your time and attention.
有没有帮我翻译一下？
Does Cloud Vigo offer anything like HashiCorp Vault for secret expressions? If you could ever just HashiCorp Vault.
可以帮我翻译一下吗？哦，可以帮我翻译一下吗？
Please repeat
So HashiCorp Vault is
HashiCorp.
HashiCorp.
the vault.
The vault.
Something that's used to store secrets.
Yeah.
Microservices. As Cloud Vigo anything or
Not yet. We haven't integrated. Okay.
Any other question?
The things you have mentioned, VS Code, so it will be like fee, right? There won't be any charges if we go with the installation of the plugins.
You're talking about the VS Code 2 will be launched soon. Yeah, it will be free. It will be available for everyone to use. You can join our Discord channel and we will know that channel you can just
Okay. And it will be available on some other IP as well, or only on VS?
We want to suppose the VS Code and components and usual. And yeah, if you have any other requirements or you can so you can provide advice to us.
No, not at all.
Okay. Okay, thank you.
Any other question on this topic?
Thank you. I have a question. Do you think that that kind of co-pilot be a tool in the future that makes sense? In addition for code generation, scaffolding, like GitHub Copilot?
Yeah, you are actually raising a very good question. In the future, we have some plans to generate code based on the large language models, right?
Yes.
You can explain more in detail.
Well, internally, we have investigated in the large language models application stuff, and we will be used in the code generation later, but not right now. Maybe a year later. Well, thanks for your attention. You may just keep in contact with us. Thank you.
Yeah, so I just want to say that Quảng Duy actually flew over all the way from Beijing and he
Yeah.
got in today a little bit nervous. So but thank you very much for your presentation. Yeah, and thank you, Kwame, for answering my
Okay, thank you. Break.
So we will continue with the next presentation. So yes, so from the update, so we got something about practical implementation with multi-runtime architecture, and I have here today technology expert from Ant Group. He also the project management committee of ByteDance, an open source solution. One sweat. Okay, are you ready?
Yes, I'm ready. Hello, everyone. I'm delighted to have the opportunity to share. This sharing is the practical implementation of multi-runtime architecture. And before we begin, I want to know how many people have heard the multi-runtime architecture. Okay, and he is my friend. And how many people have heard the Dapper project? Okay, so good. Okay, before we started, I want to introduce the origin of the name layer to everyone. And we all know the OSI divided the network into 7 layers, and layer 2 tried to define a set of standard APIs to share the difference of infrastructure. So it can be considered as the 8th layer, and 8 is auto in Italian. So this is why it's called Leto. And many people told me the name is hard to pronounce, so we can call it layer 8 or L8. Okay, let's begin our sharing. Okay, before we begin, let's take a look at the traditional application development model and the issues associated with it. In the traditional application development model, when we build an application, we need to know the details of the infrastructure. Okay, and we need to know the infrastructure details and confirm the middleware that will be used. Then I can use the corresponding SDK. For example, if we use the RocketMQ for pub and sub message, I need to introduce the RocketMQ SDK in my programming language. And similarly, if I use the Narcos as the configuration management, I need to introduce the Narcos SDK. So the model is the most common way, but it brings serious problems. First, it's not feasible to offer SDKs for every programming language. I remember there I have one. The first question for Guangming is the cloud. We go have the good ecosystem, but for other programming language, what we can do, right? So the second problem is upgrade the SDK is challenging. And the third is the application is tightly coupled with the infrastructure. And the most serious problem in Ant Group is and we all know there have many complex logic in the middleware SDK, and Guangming have showed that in the Cloud Go community, they provide many complex logic. For example, SDK. And currently in the open source community, the development and the maintenance of the SDKs is handled by the open source contributors, but internally within a company it's not feasible for the middleware team to provide all programming languages SDK. And for the second problem, upgrading the SDK is challenging, and we all know the developers the application developers also don't want to upgrade the SDK unless they meet issues or new features required. So when I develop an application which will deployed on the infrastructure A, I can develop it directly based on the details of the infrastructure A. But one day, if my application need to deploy it on the infrastructure B, what should I do then? Maybe simple way is to create two branches. The first one is infrastructure A, and the second is infrastructure B. But it's difficult for the later development and maintenance. And as a business developers, I should not have to care about these things, right? I just want to pub or sub a message. I don't care if the infrastructure uses the RocketMQ or Kafka. So I will introduce how to solve these problems in Ant Group. First, I want to talk to you about the use of the service mesh technology in Ant Group. About 2019, the Ant Group completed the service mesh transformation of RPC and moved RPC complex logic from the traditional SDK into the sidecar. And for example, the service routing, the load balancing, and the traffic governance, as Guangming have said. And Mosen is a cloud-native network proxy. Writing in Golang language is open sourced by Ant Group. And until now, there have about 4,000 applications have completed the transformation of service mesh. And we have a SRE team can upgrade all the applications sidecar every 1 to 2 months. After this, the RPC language, the RPC SDK is simple. So after complete the transformation of the RPC service mesh, we have been thinking, can we further advance the service mesh solution? And if we can move all the complex logics of all middleware from the SDK into sidecar. And in recent years, middleware team have completed the transformation of almost middlewares. As shown in the figure, the RPC, the cache, the MQ, the configure, all the complex logic have moved from the traditional SDK into the sidecar. So this makes the SDKs very simple. And let's think about it. The service mesh solved the problem. Upgrading the SDK is challenging because we have moved all the complex logic from the traditional SDK into the sidecar, and we can upgrade the sidecar without user noticing to fix bugs or add new features. But there still have 2 problems left. This is just because every middleware has their private protocol, right? Have the private protocol. For example, the Kafka and the Rocket MQ use the different protocol. So every SDK, every programming language SDK should implement them. Now I will introduce how we solve this layer 8. For the application portability problem, we all know any problem in computer science can be solved with another level of indirection, although they have another word. So we divided the middleware into the following types according to their capabilities. For example, the state is write or result data and key value model. And pub/sub interface is the publish and the subscribe message through various message quick, and the service invoke call service through Mosen and other SQL data plane. And we defined a set of standard interface for each type. So this means the application developer don't need to use the SDK interface directly with the specific middleware. For example, the pub/sub in the traditional application development, I need to introduce Narcos SDK, but no, I don't care. I can program to the abstract interface. And if I want to change the implementation from the Narcos to ZK, I just can change the configure file, right? I can change the configure file, and the new SDK can adapt automatically to the different implementation. Oh, this is good, but it's required every programming language implemented. So, the interface, and we have Mosen sidecar. So if we can make Mosen support the abstract interface, this is the lab and open source at 2021. To simplify usage for developers, we defined the interface with protobuf and employ the gRPC as the communication protocol. The protobuf and the gRPC is well established within open source community and offers the comprehensive support for various programming language, right? So any language can use gRPC with protobuf. And as the application developers, I just need to obtain the protobuf file and use the protocol tools to generate the corresponding code. And then I can access the middleware capabilities with gRPC directly. Don't need to develop any SDKs for any programming language. And if your application needs to deploy on different infrastructure, we can change the configure file through the path, and that can adapt automatically to the different components based on your configuration. Yes. So by the way, we can find the level developer based on the most. So they are one process. This means when you deploy Leto, for the multi-source mesh user, when you deploy Leto, you will have the capability to boost Leto and the most. You don't need to introduce an extra sidecar. We all know the sidecar maintenance is difficult for company. So we can use one. And next, and in the practice use, we also find there also have been a conflict between the portability and the practicality. This is, and if there have certain capabilities in component A and B doesn't, the interface definition will exclude that capabilities. So this means the application developers are limited to only can use the intersecting component, and this approach can ensure the application portability. However, we soon discovered that such an interface can't meet the needs of developers. Not all applications need the portability, but they need the comprehensive middleware capabilities. The capabilities that I can use through the traditional SDK, the new interface should be supported, right? So Leto adopts the maximal viable approach. Different with the minimal viable approach, the interface definition and the maximal viable approach is the union of all components. The application developer can use a unique capabilities to component A or component B. But when you deploy it from the infrastructure A to infrastructure B, that will retain a standard error. The component B not supported the capabilities. And at the same time, many common capabilities within on the group are not suitable for open source, but are there for integration into Leto. So for meet these needs, we provide customer extensibility capabilities. To provide the API interface definition with greater flexibility, the Leto framework supports a user-defined plugin mechanism, allowing users to easily inject their
hook function capabilities. Many teams within Ant Group have utilized this mechanism to move their common capabilities into the layer sidecar to support multi-language development. Okay, finally, let's make a summary. Service mesh moves complex logic in SDKs to sidecar, making it easier to upgrade the SDK. And let's define the status of standard APIs with protobuf and use the gRPC as the communication protocol to allow users access middleware capabilities with gRPC directly. And the layer can adapt automatically based on your configuration to solve the application portability problem. And until now, there have about 1,000 applications within the group are using Leto, covering a rich set of middleware capabilities such as RPC, state, secret, PubSub, OSS configure, and some common capabilities within the group. And Leto solves the following problems. As a standard access solution for non-Java language, different programming languages can use the middleware capabilities. And the microservice startup acceleration and the fast code start acceleration. Because as a sidecar, we can do the initialization before the fast start, before the function start. And no need to push user to upgrade SDK. User noticing. And generally, business capabilities migrate to the sidecar. It's not suitable for open source, but it's suitable for integrating Leto. And about the maintenance, in the SDI team upgrade the sidecar every 1 to 2 months for all the applications. And Leto release new version every month. So this is all of my sharing. And if you have other questions, you can contact us. The Discord channel is a new channel. I just posted this for this meeting. I think the GitHub is better. Thank you.
How does this relate to multi-runtime? Can you define multi-runtime?
This is a good question. Multi-runtime is I forgot to put the picture, but I can describe it. The multi-runtime is mean okay. Wait a moment. Here. The multi-runtime architecture means for one application divided into 5 components. The first is the network, right? The network is still Envoy and the path, the Kubernetes, and the runtime is Leto. This means for an application developer, he just need to focus on the business logic, right? I have said we don't. If I want to pub or sub a message, I don't need to care about the details of the infrastructure. I just focus on my business logic. So this is the multi-architecture, multi-runtime architecture.
I see. So it's more like a multi-layer.
No. The microservice is a high level. Microservice is a high level, and we can move more capabilities from the SDK into the sidecar. I forgot to put the picture. I'm sorry.
I'm just a little bit confused about the multi-runtime. It seems not layer or something else. That's okay.
Yeah.
Hi. We have a quote about the additional layer of interaction to solve all. So one of the big issues with interaction is cost. So I was wondering, I think this additional layer about the runtime, how much latency does it cost? Because earlier we saw a presentation where where they try to improve the RPC performance, particularly on latency when you use zero copy units. So here kind of runs counter that yet another layer. Just wondering what the trade-off here is, cost.
Okay, if I said in official, I know at the move the capabilities from the SDK into the sidecar will add the latency. Yes. About about 2 milliseconds. Yes, 2 milliseconds. But as the Guangming said, the performance is bad. If the package is big, the latency will increase about 6 milliseconds. Yes. But in the component, the first step is all the programming language can use it, and the second can use it better. So the performance is until now we don't need to care about. Yes.
Thank you.
Thank you very much. Any other question? We actually have time for one more only. So I would give it to the lady. So we. What's the difference between double?
This a good question. Different. Yes, it's the biggest difference with Dever is I think is the interface definition, and Dever adopt the minimal variable approach when defining the interface. It just ensure the application portability, and it means if you deploy an application based on the Dever interface, it can ensure your application can deploy on any infrastructure with Dever. But Leto adopt the maximal variable approach. They allow user to use all the capabilities of different middleware. And the second difference is the Leto provide the customer extensibility capabilities, allow user to support their own API.
Okay, and thank you very much. I think this is all the time we have. Once you're going to be around, right? So if you have any question, you can approach him at the end. We will share all the slides on the meetup group later, so you can go also the content. Okay, so the next presentation we have the only female speaker today, also all the way from China. Li Peng. She is the technology expert also at Ant Group and the project management committee of Progress in Gosford.
Yes, thank you very much. Hi everyone. Are you also exploring the next job of microservices? I'm Liang Lipeng, a software engineer at Ant Group and also a PMC at Catalyst. At Ant Group, we've tackled several major challenges in microservices and exploring the next job. Catalyst, a modular research and development framework, and serving platform. Today, I want to share our exploring journey with Mario. It's a little late. Let's play a game first. Have you ever developed a large application that takes several minutes to start up? Could you wave to me? Nobody? Really? Okay. And when developing business code, are you also tired of tackling the issues from making, deploying Docker images or connecting the database? Are you also dreaming someday you can only need to focus on business logic rather than the complex infrastructure? Slow start in the complex infrastructure or drag down our efficiency. And have you ever working with many developers on large applications? Have you ever encountered the conflicts when you are debugging, testing, or releasing? It's a typical scenario when your business want to split the large application into many small applications. Okay. Do you have many low traffic applications? Are you also considering how to reduce the resource cost? They really spend a lot of money. And it's another typical scenario when your business shrinks. Your business always changes rapidly, sometimes growing fast and also contracting fast. But the architecture is hard to evolve. It can change rapidly to meet business needs at a different time. So, how to solve these challenges? To solve the low efficiency and the collaboration conflicts, the higher resource costs, and the less agile architecture. Later, I will talk about the road to solution, how we overcome these challenges. Then I will introduce the secret tools we provide, like our framework and the same platform. Finally, I will touch upon our future direction. So, how do we overcome these three challenges? We employ the modularization. So, what is a module? Think of module as a simple standard Spring Boot application. So you don't need to change your programming practices. Especially, module is an application without the underlying infrastructure. By sharing the infrastructure, and the development, deployment, and start can be much faster. And we also apply module at the granularity level of development and operations, rather than the entire application, as solving the collaboration issues. And we also deploy many low traffic modules on one base to reduce the resource cost. Then we provide the tools to involve the traditional application architecture to modules like monoliths or microservices. Couplers can make your application fast as you need, pay as you need, deploy as you need, and evolve as you need. Let me tell you in details. It's a traditional application. To share the infrastructure, we cut out the part below the business layer as a base application, which only contains the common business logic and the middleware. Business layer is also the module layer. For the business developers, also the module developers, you just need to focus on business logic, making it easier to understand and develop the project. And your module can start much faster, only taking a few seconds. For the base developers, common logic and middleware management are centralized, so you can upgrade the version more smoothly. The benefits are significant. For traditional applications, it takes more than 200 seconds to build and produces 1 GB imaging, whereas modules less than 30 seconds and only a few hundred KB. And the module just takes up 70 MB in memory and it can start in 4 seconds. For large application, we divide the business layer into many modules based on functionality. Developers can manage their own module independently. And the granularity of development and operation is much smaller, thus solving the collaboration issues. For example, we had a huge application in Ant Group. It's too large, so every time we had to spend 10 minutes to deploy it, and over 30 developers were working on it, leading to collaboration conflicts and slow iterations. It took 2 weeks to release a new version. Then we split it into 20 modules. The deployment time drops to 30 seconds, and the module developers can manage their modules parallelly, allowing modules to release 3 times a week. It means that the entire application can release 30 times a week, boosting our innovation and development efficiency. For many low-traffic applications, each application can be treated as a module, and you can deploy many modules on one base, reducing the resource cost. For example, let's talk about the Nanjing F6 company. They had a lot of long-tail applications. Each application requires at least 2 machines per data center. Their CPU utilization is about 10%. So they employed couplets to deploy 6 traditional applications onto one base. This move significantly reduces their resource cost. And it also makes their application start much faster, from 100 seconds to 20. Lately, we provide a suite of tools to help you to split a large application into modules or transform application into modules, allowing quick adjustment to meet the business needs at a different time. It's very flexible. And our module can run as an independent process or as a module with other modules deployed on one base. Then let's talk about our secret tools, the core capabilities of Catalyst: modules, sharing, isolation, and our new serving platform. So how to produce a module, how to design the isolation and the sharing between them. We know module is a standard Spring Boot application without the common business logic nor middleware. So we just needed to set the common dependencies as provided. And the module is built as a jet package rather than the Docker image. So it can be built much faster and support hard deployment, which means that no server restarting is needed when deploying the module. And to ensure the and object isolation. And we also use a class delegation and provide cross-module object finder for class and object sharing. Then let's talk about our serving platform. In Catalyst, our base runs in a pod and our module runs in a base. So we should design a module scheduling to allocate the modules to their bases, thus creating a 2-tier serving platform. Usually, we will construct a new module controller, but it's high cost and also hard to adapt for different companies because they always build their own serving platform. So how to solve it? We use virtual kubelet to map our base as a virtual node and our module as a virtual pod. So we can use Kubernetes deployment, scheduler, and controller manager for module serving. This approach leverages the existing Kubernetes framework, so we don't need to build any extra infrastructure. It's much easier to understand and adapt for other companies. For example, when storing modules in virtual Kubernetes, we just create a module deployment through the Kubernetes controller. And then the Kubernetes scheduler will assign the virtual pod to a virtual node. When our virtual Kubernetes finding a virtual pod is assigned to its virtual node, and syncs the virtual pod, virtual node, and the pod states. We can also use Kubernetes service to isolate modules traffic. So far, Kubernetes has been published at Ant Group for 5 years. Since the open source of Server Arc in 2018, the following year, we set up modular research and development framework based on Server Arc, which is Server Serverless. And after several years of refinement, Server Serverless 1.0 was released last year, and they have already taken 400,000 calls in Ant Group. And they also have received much recognition and praise from many internal developers. So we decided to open source it. And as for now, it has reached 700,000 calls in Ant Group. And in the community, more than 20 companies is using it. In summary, Kubernetes aims for 4 goals: speed as you need, pay as you need, deploy as you need, and evolve as you need. For speed, you can develop fast, start fast, and release fast. And developers can only focus on your business, and everything can run parallelly to achieve higher efficiency. For pay, our module don't cost any extra machine, so you don't need to pay for it, and it only uses a small amount of CPU and memory in the base. And we also design modular static scheduling to achieve higher resource. Our module can run as an independent process or as a module with other modules based deployed on one base, so you can adjust your deployment strategy flexibly to meet your business needs. And also the flexibility also extends to your changes, which is only limited to your module and its corresponding machines. For evolution, you can split the existing application into modules or transform it as modules. These modules can then evolve into microservices or revert back to monoliths. So how about the future? This is our original intention and also our goal. Let traditional applications evolve to a serverless mode at a low cost. We want the evolution to be affordable and feasible for legacy applications, not only for the new one. And it also sets Kubernetes apart from other service platforms. So far, we have open sourced the initial versions of Kubernetes runtime framework, development tools, architecture, and the serving platform. And we have served more than 20 companies. Recently, we will release multiplication data frameworks. And in Q3, we release a new version of certain serving platform. And further ahead, we hope we can collaborate with community to exploring the modularization together. We value sharing, communication, collaboration. If you are interested in Kubernetes, please feel free to scan the QR code to join our discussion group. You can connect us with Discord or GitHub or WeChat or LinkedIn. And do you want to experience 20-second modular deployment? Welcome to our booth and give it a try. Thank you. That concludes my presentation.
an increase in service mesh with a solution also by this company, Microservices.
Okay, thank you everyone. I know now it's too late, so my speech will not be very long. And my name is Jerry. I'm from Cloud, and now my role is solution architect, and also I am responsible for our company's strategic business development. My topic is building an efficient service mesh. My presentation will include 4 parts. The first one is introduction and the technical background, and the second one is implementation and the challenge of ambient mesh. Third one is optimizing ambient with eBPF and bridge. And the last one is issues, performance, and also community resources. So first, give me 2 minutes to introduce our company and our team. Cloud may be not as famous as Ant Group, ByteDance. They are a very large company. Cloud is a small company, but we are now innovative leader in cloud native and also application modernization area. So our company is founded at end of 2014. For the past 10 years, we continue to contribute to the open source community. So as you can see on the right part of this slide, there are many famous open source projects. Most of these projects are about microservices, like ES2, like Prometheus, like other famous open source projects. And a small number on the right corner of each icon is the global ranking of our company. So now we ranked number 3 in Kubernetes and ranked number 2 in ES2 in the past year. So now we have 2 CNCF ambassadors and 1 Kubernetes steering committees and also 1 ES2 steering committees. So first I will introduce ES2. It's a CNCF graduated project. So it's a popular project used in many service mesh projects to control the traffics between services, so developers can easily control the traffic. They don't need to hard code the rules in the code. So this project was funded by Google, IBM, and lived in 2016. And now it's it have more than 36,000 and also more than 34,000 commits. And now in Cloud, we have 3 maintainers, and also we have 43 members of this project. And Cloud contribute many to this project. So now we have 1 ES2 steering committee in this project, and ranked number 2. And we contribute to like new modes and new architectures to support supporting many new modes of ES2. And also we developed many features like analysis, check, inject, and also waypoint commands, and fix over 100 issues in ES2 control. So what is E2? As I mentioned before, it's an open source service mesh project. So it uses sidecars to control the traffic from service A to service B. We have proxies to redirect the traffics between them. So it secure by default, increase observability, and also it can manage traffic. So then I will introduce MoBridge. MoBridge is now it is CNCF and also a landscape project in eBPF. So why we create this new project? We have Istio now, but Istio use IP tables to control the traffic. It has many limits to use in the enterprise enterprise cases. So we create MoBridge to use eBPF instead of IP tables to improve the traffics and also accelerating the speed. As we can see, the speed can be increased nearly 10%. So this is a repo URL, and now we have more than 700 stars and 400 commits, and also 25 contributors. Nearly 2 years ago, and now Kuma and ASM to accelerate the speeds in their service mesh network. So what the MoBridge do is to use eBPF to replace the IP tables, and also we simplify the traffics between the services, between the ports. As you can see, I use two red circles to show this. As you can see, we simplify the traffics. Before MoBridge, the traffic from port 1 to port 2 is a very long journey, and after it's simple. And if the two ports are located in one node, the traffic will be the route will be simple. So when to use MoBridge? If you need high performance connections, where IP tables increase because many they may conflict each other. The third thing is maybe you have security concerns to limit the permission. You have limited permissions for some ports, so you can use MoBridge. You can try MoBridge. So then the part 2 is the implementation and the challenges of ambient mesh. What is ambient mesh? Ambient mesh is a new data plane proxy mode because it still use sidecars to control the traffic. A sidecar may have may increase the resource utilization. So this new mode named ambient is use the node proxy and also waypoint mode to reduce the resource usage and lower the difficulty of use compared to the previous sidecar mode. So this is the traffic between the two ports. As you can see, the ambient also use IP tables by default. So it use Z-tunnel to control to proxy the traffics between the two services. or also use policy routing. So this may causing issues. So ambient mode isn't compatible with all CNIs. To address this, maybe you can maybe you can use eBPF to solve these problems. But if you use eBPF to if you want to use eBPF to solve this problem, it can be done in some scenarios, but not all scenarios. So as we researched, there are some problems with ambient eBPF mode to control the traffics between two ports. However, it relies on the CNIs with peer network interface. So many other there are some CNIs have no peer network interface like MacVLANs. So ambient mode eBPF mode also cannot be used in this scenarios. So we tried to use Mobridge to enhance the ambient mode. So we many other CNIs. So how to handle the traffic forwarding by default ambient mode? It's by matching whether the source IP of the traffic is ambient mode on the host. It is determined whether to forward the traffic to the tunnel. But the eBPF program of Mobridge will directly determine whether the traffic needs to be forwarded to the tunnel when the process is in the port initialize initiates the request. So I will not because of the time. So we solved some problems, but not all the problems. So there still have many known issues in this in Mobridge. So the first one is original source. The second one is message redirect. The last page is about the performance. As I mentioned before, we use eBPF to accelerate the network, and also we can adapt to many other CNIs. So this is the we do a stress test to compare the Mobridge with the IP tables both. So we have nearly 5% to 10% performance improvements. It's not a very big improvement, but we are working on this to maybe we can achieve more. So these are the community resources. If you are interested with what we do, what we are doing, and also if you want to use our project, or if you want to contribute to our project, so you can scan the QR code. The left one is the Mobridge's repo. The right one is Slack. You can join our Slack channel to talk to us. If you have any questions, if you want to have a try, or if you have more requirements, need us to know. Then, if you're interested in our company, you can scan the code to QR code to follow our LinkedIn page. Also, you can visit our official website. We have many open source projects showing on our official website. So that's all.
Any question for all the speakers? They are still here from the beginning until now. Any question?
Basically, I'm using Microservices a lot. It still has an operator that we can use OpenShift.
Is to you.
It still has an operator, but does Merge also have an operator?
Operator, yes, also. Sorry, Merge is not have operator. We are simple simple application demonstrate. So you can run just use one command. It is very simple. So yeah. Thank you.
Anyone else?
I want to clarify that because I am not the developer of this project, so maybe I cannot answer every question, but I can write down the questions.
Okay, very good. Thank you, Cherry. Yes, so we still have a few present here. I think we don't have any questions now. Maybe a speaker should ask a question.
Yeah, thanks for the presentation. Thanks for everyone who was here in this room. And I found that previously we have some questions not being answered yet. So if you're still interested, you can hear, well, we can create it. Okay, please hand the microphone to this man, to this sir. Yes.
I apologize. This is a variant of my earlier question, but I was wondering if any of the presentations we had today, any of the solutions actually have a modular secrets and injected into the mesh, and in the other solutions as well. Do they have maybe a modular secrets management solution?
Okay. May I ask your background? Are you from HashiCorp or?
No, I'm a DevOps engineer. I'm from Accenture Consulting.
Oh.
So we're always looking for alternatives to HashiCorp Vault.
Okay.
Costs.
Because of the license problem, right?
Among other things, the licensing. And for example, some areas like Hong Kong, the companies we work with, they cannot use HashiCorp Vault without a local local vendor, and there is no local vendor in Hong Kong that directly represents HashiCorp. So we struggle to find people who support HashiCorp Vault, so we look for alternatives.
I think you are mentioning very interesting points. Actually, we have discussed this with the CNCF's CTO before. He asked for us the same question like you did today. Indeed, it's very important issue in this, especially in the cloud native ecosystem. We might want to find a new solution. Unfortunately, right now in ByteDance we have our own system. It's not open source yet, but we might be able to figure out a new way, maybe in the future. And right now, not right now. That's not yet. It's not open source yet. But I will remember catch up your question. Thank you.
Just to note at the last point, this is a problem we find throughout Greater China for customers we have in Greater China, not just Hong Kong as well. It's a problem we're finding with our customers there. We don't really have a vaulting solution.
Okay. Thank you. Thank you. Do anyone have any questions related to RPC scenarios? Because we also have the another maintainer of KaiNext project in Yari is also here. She can also answer some of the questions if you want to ask. RPC scenario, especially in massive production. Okay.
Yeah, so I was talking about so I was quite interested in the Kydex itself. Okay, so particularly the aspect of zero copy. So the thing is that so if I remember correctly, the way it does it, this is basically allocate, or basically an index directly into the request or response. It means the index feels directly from the memory block allocated to the request or the response. So generally that works very well. But I'm just curious about how do you do it, particularly on the allocation side. Wondering how do you deal with variable with fields like strings, for example, where you how do you allocate a block and still account for strings that can have variable length?
Okay. I think you are
organization of this event. As mentioned earlier, we also run events in other cities around Asia. The next one will be in Bangkok. So you can join the chat group in order to check out more events from us. Thank you very much, and I wish you have a good evening. If somebody still wants to try out the 20-second deployment, it's over there.
Yeah, that's right.